Hi there. In the other half of the 1.4 section, we will be talking about unit conversions. You will first see a chart of a variety of conversion factors. Any conversion factor that you see in this chart would be given to you on the exam. Now, some conversion factors will not be given to you. For example, 1 foot is equal to 12 inches. That is something that I would expect you to know. Similarly, 1 minute is equal to 60 seconds. That also would be something that is not given to you. When we work with conversion factors, some of these numbers are approximate, but you will notice that some of them are exact. And that's because we are not going to take any exact numbers into account when we're looking for our rounding purposes. Also, in addition to that, 1 foot and 12 inches, 1 in the 60 in seconds are all going to be exact because they're found by a counting process. There are exactly 12 inches in 1 foot. There are exactly 60 seconds in 1 minute. Okay, now let's see how we're going to use these. Example 3 says performing the following conversions and use the rules for precision and accuracy for rounding. Assume all values are approximate unless stated otherwise. Let's start by just diving into an example. We want to change 2.5 pounds to grams. Now, you may have learned conversions one way, and that's okay if that's how you want to approach them. I'm not going to be as concerned with which process you use as long as you are using a process that helps you get every problem correct. If you find the process you are using isn't always effective, or you're not sure whether to multiply or divide, then you should resort and try the process that I am showing you. We are going to start by whatever the measurement being given to you is. In this case, it's 2.5 pounds. So we have 2.5 pounds. We'll start with that. Since there's no other measurement that we're starting with, we're going to put this over a 1. You will notice if we look down example C, it says miles per hour. There would be 2 measurements there, miles an hour. Then you would move one of them to the denominator. Okay, continuing with this one. After we have the starting point, now we have to multiply this by a conversion factor. So what goes in here is a conversion factor. That's always going to be step 2, which means we are going to take something from this chart or something that we know and put it into the parentheses here. We need to convert it from pounds. We need to get rid of the pounds. So when we use the conversion factor, we want to put what we're trying to get rid of in the denominator. The reason being is so we can cancel pounds for pounds. Just like we looked at in the first part of 1.4, if we have something like x divided by x, it's 1. These will cancel out in the same manner. We want to go from pounds to grams, so grams goes in the numerator. Now what we have to do is look up for our conversion factor that works with pounds and grams. Well, pounds is weight, so we know we want to look for under the weight grouping to find the conversion. And we can see it's the first one here. 1 pound is equal to 453.6 grams. You have to make sure you put the 1 in the 453.6 with its correct measurement. So it's 1 pound, so you have to put the 1 in the denominator next to the pound. And it's 453.6 grams, so you have to put that next to grams. If we were converting from example grams to pounds, everything in this conversion factor would be switched because our numerator and denominators would have to be different. You can always double check that you set up your conversion factor correct if you can cancel a pound in the numerator and a pound in the denominator. Also double check that you did your conversion right. 1 is next to the pound, 1 is next to the pound. Okay. Now at this point, we multiply our numerators together and then multiply our denominators. So multiplying our numerators, we take 2.5 times 453.6 and we get 1134 grams. Don't forget that unit. Now the denominator, if we multiply this, it would just be 1 times 1. I'm going to write this here just so we can see what happens. Well, 1 times 1 is 1. Always make this division. In this case, it's just going to come out to be the 1134. So we have this 1134 grams. Now, the last thing we have to take into account is it tells us to use the rule for precision and accuracy for rounding. We multiplied here, so we have to look at the accuracy. And we always go to the original measurement, which in this case, the 2.5 is 2 sig digs, which means that we want to round our final answer to 2 sig digs. So when we do this, 1,134 rounding the 2 sig digs, right, that would just be 1,100 grams. Good. Let's look at another example together. We want to change 192 inches squared to feet squared. Okay, inches to feet. That's one of those conversions that we know. We have to start with 192 inches squared over 1, and then we want to set up our conversion rate. However, we know that 1 foot is equal to 12 inches, but we might not know off the top of our head how many square inches are in a square foot. So we have to approach this problem slightly differently. Now, if we kind of back up a little bit and we think inches squared could actually be written as inches times inches. That'll help us when we need to convert this, because now we can see really what we're working with. Just like we did in the previous problem, if we have pounds in the numerator, we have to put pounds in the denominator. So therefore, we put in inches in the denominator, and we put feet in the numerator. We know that the conversion from inches to feet is 1 foot for 12 inches. Make sure you line these up right. 1 foot is 12 inches. And we can see that we can cancel an inch with an inch. However, if we multiply straight across, we still have an inch and we only have 1 foot. So how do we get rid of the other inch? Right, we have to do one more conversion factor. Again, since we have inches in the numerator, we need to put inches in the denominator, and we're converting it to feet. 1 foot is 12 inches. And we can see now this other inch will cancel with the other inch. Now when we go to multiply straight across, looking at our numerators, we have 192 times 1, which is 192. We also have feet times feet, which we know would be feet squared. But we also have to look at the denominator now, since we have things other than just a 1. We have to take 1 times 12 times 12, which is 144. And there are not any units that we have to multiply there because they've canceled out. We don't want to leave our answer like 192 over 144, so we have to divide this. We take 192, divide it by 144, and we are getting 1.3 repeating, I'm just going to write it like this, feet squared. Well, we have to use our precision accuracy. Again, we're multiplying, so we want to use accuracy here. And when we do this, we see that 192 is 3 sig digs. 3 sig digs. So we have to look at the first 3. Therefore, our adjusted answer would be 1.33 feet squared. Okay, let's look at another one. This time, we want to change 45 miles per hour to feet per minute. This one we have to set up a little bit differently because now we have 2 kinds of units being given to us in the original measurement. We have 45 miles. We can think of that as per 1 hour. So this we want to set up as 45 miles per, which is what the P stands for, 1 hour. Now we still have to multiply using these conversion rates. We have to convert the miles. Well, does that go to feet or minutes? Well, that can only go to feet, miles to feet, and then we have to convert hours to minutes. Since we have to convert 2 separate units, that does tell us we will need 2 conversion rates. We have to do a miles to a feet and then in hours to a minute. It doesn't matter which one you do first. I'm going to start with miles because that's in the numerator. So we have to go from miles to feet. Well, look up top if we need to figure out miles and feet. So length, we have miles and feet. It's this bottom one here. It says 1 mile is 5,280 feet. And we can see that we can cancel miles to miles. Before we complete these operations though, let's go ahead and do our last conversion. This one's a little bit different. Hours in the denominator, so we have to put hours where? Right in the numerator because they have to cancel. And we're converting hours to minutes. We know that 1 hour is 60 minutes. And we can see the hour in a denominator cancels with the hour in the numerator. Running out of room here, but we'll squeeze it in. So now we multiply across the numerator. So we have to take 45 times 5,280, which, let's see if I can squeeze this in. We get 237,600, and the only units we have here is feet. And we have to divide this by 1 times 1 times 60 is 60, and this would be feet per minute. And then last thing we have to do is make the final division where we divide the 237,600 by 60, and we're left with 3,960, and this would be feet per minute. Lastly, we have to look at rounding. Here we have 2 sig digs, so our final answer needs adjusted to 2 sig digs. What I want you to do is pause the video, see if you can round that number correctly to 2 sig digs. Now when we go to round this, since we want 2 sig digs, we have to look to the right, which is a 6. The 6 is going to bump the 9 up to a 10, which ultimately bumps the 3 up to a 4, so it would look like 4,000 feet per minute. However, that's not 2 sig digs. 4,000 would only be 1 sig dig. In order to make it 2, this is when we have to put a tag over that 0. Remember, a tag makes a 0 significant. We only ever put tags above a 0. We want that 0 to be significant, so we have to tag it. Now it's 2 sig digs. Okay, the next one. Water flows from a fire hose at a rate of 85 gallons per minute. Convert this to liters per second. I want you to try this one on your own. It is going to be similar to letter C because we have 2 different units in the original measurement. Again, look at the chart to find your conversion if you don't know it. Pause the video, try it out. We should get an answer here of 5.4 liters per second. We start with the original measurement, 85 gallons per 1 minute. And we have to convert gallons to liters and minutes to seconds. So we know we need 2 conversion rates because we have to make 2 separate conversions. If gallons is in the numerator, we have to put gallons in the denominator and then the liters in the numerator. Up at the chart, I highlighted it in red, 1 gallons. We put the 1 next to the gallon, 3.785 liters. The gallons will cancel. And then minutes is in the denominator, so we have to put that one in the numerator. 1 minute is 60 seconds. Multiply your numerators, multiply your denominators. We have liters per second. 2 sig digs would round to 5.4. Okay, let's look at this last one. A little bit different. We're going to use our information from the first half of 1.4 and what we've learned in this one to complete example E. Perform the indicated operations and attach appropriate units to our answer. The 60, the 1, and the 5,280 are exact. When we look at this problem, there's one thing that should stand out first, right? And that is this outside exponent. Remember, we always have to address them first, which means there are 2 factors of the 1 minute and 60 seconds. So what I can do is kind of just get rid of this 2 here and add the other factor, 1 minute, 60 seconds. Now we have 2 factors of this. By expanding it out, we can now see what we're working with. What we can do is start canceling things. Well, I have a mile in the numerator, mile in the denominator. I have, let's see, what else? I have a minute in the numerator and a minute in the numerator, which will not cancel. I have 2 seconds in the denominators, which don't cancel. But I have this minute squared down here. Remember, minute squared would be minute times minute, which means one of those would cancel with the first minute and the other one with the second. So all those minutes, minute times minute, and then minute and a minute. So now we're left with feet per, and then we'd have second times second, which would be second squared. So we at least know our units. Now in this case, we just have to multiply the numerators, multiply the denominators. So going in the numerators, 8.75 times 1 times 5,280 times another 1 leaves us with 46,200, and we have a feet up there. And we have to divide it by 1.32 times 60 times 1 times another 60, which is 4,752. Second times second is second squared. Last but not least, we have to make that division, 46,200 divided by 4,752, and this would leave us with 9.72 repeating feet per second squared. So now as far as our accuracy goes, we're using multiplication. We know the 1, the 60, the 5,280 are all exact. So we're looking at the first two, 1.32, 8.75, both have 3 sig digs. So our answer would have 3 sig digs, 9.72 feet per second squared. Okay? That completes all of section 1.4. Please reach out if you have questions.